All right, everybody. So we are going to start with Regents Review Packet number 1 with these practice Regents questions. So it says, base your answers to questions 1 and 2 on the data table below, right? This is the data table, which shows the amount of water vapor in grams per cubic meter that will saturate 1 cubic meter of air at different temperatures. All right. So number 1 says on the grid provided in your answer booklet, construct a line graph of the data following the directions below. So A, place the name of the correct variable along the y-axis, include the correct units. B, mark an appropriate numerical scale showing equal intervals along the y-axis. And C, plot the amount of water that will saturate 1 cubic meter of air at the temperature shown in the data table. Connect the points with a smooth curved line. All right. So one thing just to keep in mind, right? They want you to label the y-axis. If the x-axis is temperature, then the y-axis title is going to be water vapor, and the units are below. And when you're plotting numbers, right? So let's say if I started here, right? If I started here at 0, you have to make sure that each line goes up by the same amount. So it can't be, hey, I want each line to go up by 2, and then after that, I want the next couple lines to go up by 5. It has to be the same amount. So I see 0, I can do every 2. 2, 4, 6, 8, 10. So then therefore, I can put 10 here. 12, 14, 16, 18, 20. 12, 14, 16, 18, 20, right? And so forth. And so they want you to label the y-axis. They want you to plot the data as well. And so if you look right here, I'm just showing you, you're free to pause this. This is what your graph should look like. When you get a question like this on the Regents, this is a free point. Make sure that you double check your values. Make sure that you're not just rushing this, all right? Because this is a free point to make sure your numbers are matching up correctly, all right? Make sure always to use pencil when drawing a graph as well too. All right, you can pause this. This is your answer for number 1, A, B, and C, and water vapors on the y-axis with the units. All right, number 2. Number 2 says describe the relationship between the air temperature and the amount of water vapor necessary to saturate the air. All right. So when I look on my data table, all right, one thing I'm going to look is I'm going to look to see as my air temperature gets warmer, all right, what's happening to the amount of water vapor, right? What's happening to the amount of water vapor? So if once I'm going from -20 to 10 to 0, right? What is happening with my water vapor? It's going from 1 to 2 to 5. But I'm going from 0 to 10 to 20 to 30. I'm going from 5 to 9 to 17 to 29 to 50. So it looks as though as the air temperature increases, what's happening to the water vapor numbers? It's also increasing as well. So anytime you get a question that's asking to describe the relationship, they want to know as one variable is increasing, what is happening to the other variable. So describe the relationship between the air temperature. So as air temperature is increasing, what is happening to the amount of water vapor? Well, we see right here, as air temperature is increasing, your water vapor is also increasing. And so this is your answer for number 2. All right. So it's a direct relationship. That means when one category is increasing, the other category is increasing as well. All right. And if you take a look on, I apologize, on fact 2A, oh, sorry, let me scroll here. There we go. All right. They tell you how your graph generally looks, right? So if your line is generally going diagonally up, right? That shows you a direct relationship, right? As the x-axis is increasing, so does the y. And you can look on graph 2 to kind of see the other types of relationship. So once again, if you get a relationship question, right? Is it direct? Generally, it's going to be, for the most part, it'll either be between a direct relationship or an indirect relationship. All right. And most phenomenons, natural phenomenons, right, or environmental changes that occur are usually cyclic and predictable, right? Like the tides, moon phases, as well. Number 3, the graph below shows the tidal changes in ocean water level in meters recorded at a coastal location on a certain day. Approximately how many hours apart were the two high tides? All right. So the high tides are here. And when I look to give an estimate, right, it's kind of halfway. So it kind of looks like it's right, 9 a.m., right? And then the next high tide also looks kind of halfway. So it looks like about 9 p.m., right? And so the time difference between these 2 points, right? 9 a.m. to 9 p.m. The best answer will be 12 hours. And we just remember with tides, right? They're cyclic and predictable. All right, number 4. Number 4 says, as air on the surface, as air on the surface of Earth warm, the density of the air does what? So when we compare the density between the two, right? Remember, warm air rises, right? Warm air rises and cold air sinks. And cold air sinks, right? Why does cold air sink? Because the density is higher. The density is higher. Warm air rises because the density is lower. So as the air on the surface of the earth warms, the density actually decreases. All right, number 5. In the first picture, the sphere is in a beaker with 100 milliliters of water. In the second picture, the mass of the dry sphere is being taken. Which of these values listed is closest to the density of the black sphere? All right. Now, when we go to our note sheet, right, and this is actually located on the reference tables, density is equal to mass over volume. All right, density is equal to mass over volume. It's actually in a reference tables right over here. Density is equal to mass over volume. All right. So that means for this black sphere, right, I need to know the mass of the sphere and the volume of the sphere. Well, first off, this is a scale. And when you put an object on a scale, it actually tells you what the mass is. So the mass is actually, and I'll write the formula here, right? The mass is actually 70 grams. But now we have to find out what is the volume. The question says that the black sphere was put in a beaker of 100 milliliters of water. However, I see that the water has risen to 150, but they tell us that the sphere is in a beaker with 100 milliliters of water. So where did this extra 50 come from? Well, that extra 50 actually came from the black sphere, right? If we started off with 100, we started off with 100 milligrams, I'm sorry, milliliters of water, right? I put the black sphere in, and now the water level rise to 150. What made that difference? The black sphere did. That's why my volume is going to be 150 minus 100, and that gives me 50 milliliters. That's why my formula, 50 milliliters. And now when I do 70 divided by 50, you end up getting 1.4 grams over milliliters. And that is choice 3. Number 6, the graph below shows a relationship between mass and volume for 3 samples, A, B, and C of a given material. What is the density of this material? Well, remember, let's look at our formula again. Oops, sorry, right here. Density is equal to mass over volume, right? So therefore, I'm going to apply that same formula. Density is equal to mass over volume. So from that point, you pick any point on this chart. You can choose point A, you can choose point B, you can choose point C. I'm just going to pick choice. I'm going to pick point B. So at point B, mass is 20 grams. So my formula, mass is 20 grams. And then at point B, my volume is 2 milliliters. Density, 20 divided by 2 gives you 10 grams over milliliters. All right, and so my correct answer is going to be choice 3. Oh, sorry, not milliliters, because the units say right here, cubic centimeters. Number 7. In which two Earth's regions is oxygen the second most abundant element by volume? All right. When they're talking about, anytime you get a question where they're asking what is the most abundant, what's the second most abundant element, right? Whether it be by volume or mass, let's take a look at page 1 of the reference tables. All right. Because page 1 gives us a chart that shows us the element percentage by mass and volume in the crust, the hydrosphere, and the troposphere. All right. And so in the question, it says, is oxygen the second most abundant element by volume? So I have to look on the first page of the reference tables and look, where is oxygen the second highest number by volume, not the first highest. So the crust can't be it, because look, oxygen is 94.04. That's the highest. So it can't be the crust. The second most, right? Well, when I look at the hydrosphere, the first is hydrogen and the second is hydrosphere. So that's fine. And I look in the troposphere, the first most abundant element by volume is nitrogen. And the second most, 21%, is the troposphere. So the hydrosphere and troposphere is correct, which means it is choice 2. All right, number 8. What is the inferred pressure in millions of atmospheres in Earth's interior at a depth of 2,900 kilometers. Well, what page am I going to go to find the inferred pressure in millions of atmosphere in Earth's interior at a depth of 2,900 kilometers? All right. All of these key terms that I hear about, pressure in millions of atmosphere, the Earth's interior, that's all going to deal with page 10 of the reference tables. So let's take a look. And look, the inferred properties of Earth's interior, and the problem literally said, what is the inferred pressure? Right? And I'm looking at the pressure in millions of atmospheres, just like we highlighted right here. And they want to know the depth. They want to know the pressure when we have a depth right here of 2,900. So 2,900, I'm going to zoom in. 2,900 is right before 3,000. So 2,900 is actually going to be right here where this dashed line is, right before 3,000. So when I climb up, I climb up, I climb up, and I'm not going to temperature. I'm climbing all the way to pressure. And I hit the black line on pressure, and I look to the left, and it definitely looks between 1 to 2 million, to 1 to 2 million atmospheres, somewhere in between that, right? So what is the best answer between 1 and 2? Choice 1. Number 9, at what approximate altitude in the atmosphere can stratospheric ozone be found? Stratospheric ozone be found. All right. So I'm going to look at what page of the reference here where I could find the stratosphere. All right. And I'm going to test out all of these altitudes. All right. Remember them. So I'm going to go to what page, everybody? Page 14. All right. And we'll be able to do the process of elimination. They tell you right here in kilometers, the numbers are going to be, for altitude, is going to be on the left side. All right. So keep that in mind. We're only focusing on the left side. All right. So let's do a trial. So I'm going to highlight. So I'm going to find 10 kilometers first. And each line actually goes up by 10 kilometers. We're looking at the left because kilometers is on the left. So when I take a look, I got 0 and 10 is right here. And if you notice, 10 is still focusing on the troposphere. So it can't be 10. Let's see, 30 kilometers. I'll put a different color. And 30 kilometers is right here. And when I take a look, we are hitting the stratosphere. All right, so that's a possible answer. Let's take a look at 70 and 100. All right, well, let's take a look at 70. So 70 is going to be right here. And look, 70 is part of the mesosphere. And 100, 80, 90, 100, right? Which, sorry. So 100 is right here. And that means I'm part of the thermosphere. So the one that's part of the stratosphere is this one right here, which ends up being the 30 kilometers. And that ends up being choice 2. All right, number 10. The diagram below represents Earth at one position in its orbit around the sun. Starting at the North Pole, draw a straight arrow that points to the location of Polaris. So it says starting at the North Pole. So my North Pole is right here. Starting at the North Pole, draw a straight arrow that points to the location of Polaris. So Polaris is the North Star. And it says right here, Polaris is located directly above the Earth's North Pole. So that means Polaris is going to be directly above the North Pole. So that's how I draw my arrow, going straight up above the North Pole. Let me draw it so that better. There we go. So Polaris is directly above the North Pole. Number 11, it says the diagram below shows an observer on Earth measuring the altitude of Polaris. What is the latitude of this observer? Well, in your reading, we stated it right here. The altitude of Polaris equals your latitude in the northern hemisphere. The altitude Polaris equals your latitude. And altitude of Polaris is an angle in degrees only. Do not write direction when you're finding the altitude of Polaris. So what is the, right? What is the latitude of this person? Well, let me find the angle, right? Or the altitude of Polaris is right here, 66.5. It's always going to be the angle that starts from the horizon and heads to Polaris. So it's this angle right here, 66.5. So if my angle is 66.5 degrees, then my latitude is going to be the same number, but degrees north. That's why the correct answer is going to be choice 2. This person is located 66.5 degrees north because they're asking for the latitude. 66.5 degrees is just the altitude of Polaris. Remember the difference between the two. One is degrees north, the other is just degrees. Which graph best represents the relationship between the latitude of an observer and the observed altitude of Polaris above the northern horizon? All right, so the relationship between the latitude of the observer and the observed altitude of Polaris. Well, we just learned right here. The altitude of Polaris is equal to your latitude. That means that if my latitude gets bigger, so does my altitude of Polaris. So if my latitude is going from 0 to 90 degrees, that means my altitude of Polaris has to also go from 0 to 90 degrees. And that's why the correct answer is choice 2, right? When I'm looking at 90 degrees north, I'm also looking at the altitude of Polaris, 90 degrees. All right? They're equal to each other in value. All right, number 13. So it says, at which New York State location will an observer most likely measure the altitude of Polaris as approximately 42 degrees? Well, remember we learned that the altitude of Polaris, all right, I know I spelled this wrong, sorry. Altitude of Polaris is equal to, here you go, is equal to an observer's latitude. All right, and it has to be in degrees north. So I'm gonna find 42 degrees at the altitude of Polaris. That means I'm gonna look for what city is also located at 42 degrees north. All right. So when I'm looking here, I'm going to estimate to see which of these cities are also going to be close to 42 degrees north. All right. Because my altitude of Polaris is 42. So I'm going to circle these four cities: Jamestown, Plattsburgh, Oswego, New York City. All right. Jamestown, Plattsburgh, Oswego, New York City. Okay. Let me do. All right. Jamestown is here. Plattsburgh is located right here in red. Oswego is located right here in orange. And New York City is located right around here, right? Right around here in brown. And so the one that's closest to 42 degrees north is Jamestown. That's why the correct answer is going to be choice 1. Number 14, the map below shows 4 locations, A, B, C, and D, on the continent of South America. Which location is the first to experience sunset on September 23rd? So, guys, we have to remember, right? The city that sees sunrise and sunset first is the city, is the city that is most eastern, the most eastern city. All right. So the city that is most eastern is going to experience sunrise and sunset first. So between A, B, C, and D, which city is most eastern is going to be D. It's a city that's closest to, well, the most east, right? If the question said which city is the last to experience, then it would be the most western. That's the reason why New York, right? New York's time is ahead. We see sunrise first as opposed to California, right? So when you head to the east, time increase. When you head to the west, time gets less, right? When we're doing time zones. So the most eastern city is going to be the time that is the city that's most ahead. That's why it's choice 4. All right, 15. The map below shows a portion of the Middle East. Points A, B, C, D, and X are locations on Earth's surface. When it is 10 a.m. solar time at location X, which shows at which location is 11 a.m. solar time being observed. All right. So 15, we want to look at 5DI, right? And 5DI2. So we are basically looking at right here. Okay. So we know that every 15 degrees is equal to 1 hour. And as you head to the east, time increases. So they're saying in this problem that the solar time at X right here, well, I should put it up here, right here is 10 a.m. All right. And they're saying which letter is going to be 11 a.m. Well, we just said as you head to the east, time increase. We're looking for 11 a.m. 11 a.m. is more later than 10 a.m. So that means my answer has to be towards the east, to the right of X. Now, we also said 15 degrees is equal to 1 hour. So if I start here and each box is 5 degrees wide, right? In order for me to get 1 hour ahead, I need to move 15 degrees to the right. So 5, 10, 15 degrees to the right. And so that's why my correct answer is choice D. All right. Remember, as you head to the east, time increase. All right, number 16. Number 16 says which latitude and longitude coordinates, oh, sorry, represent a location on the continent of Australia. When I'm looking at the choices, right, it's either south, west, south, east, north and east, north and west, right? It's the same numbers. So let me point, let's just plot everything else, all right? Let's plot everything else. So we're gonna go to page 4, all right? Because page 4, I am allowed to find Australia, all right? Keep that in mind. So we're gonna plot all 4 coordinates. So let me see, it is 20 degrees north and 135 degrees east in those numbers. So I'm gonna plot all 4, all right? So 20 degrees north is right here, right? This is the north. This represents the north side. And 135 degrees east, let me put this right here. Remember, to the right of 0 is east, right? It stops at 20 and then it continues on the other side. So 135 east is right here. So 20 and 135 east is right here. That's choice 1. Let's get you take a look. 20 degrees north, for this is choice 2, and 135 degrees west. So let's do this. 20 degrees north again, right here. And 135 degrees west is going to be right here. That's choice 2. Choice 3 is going to be 20 degrees south and 135 degrees east. So 20 degrees south is right here, right? It's below 0, which means that it's going to be south. Sorry. 20 degrees south is right here. North is up here. 0 splits between. And 135 east. 135 east. Remember, right here is east up until it gets to 180. And this is degrees west. This separates, and this is degrees east. And so when I take a look, boom, choice 3 lands on Australia. That's why the correct answer is choice 3. Number 17, what is the approximate location of the Canary Islands? All right, so where do I find the approximate location of the Canary Islands? Well, I know it's definitely going to be close to the Canary hotspot, right? The times where I've seen the canary, even the word canary, right? Even the word canary, I see it right here, right? Canary Islands hotspot. And when I'm guessing, right, when I want to estimate this latitude, right? Remember, north is above 0 degrees north. And degrees south is going to be below 0. So Canary Islands hotspot definitely looks to be, right, a little over 30 degrees north. And to the left of 0 is degrees west. To the right of 0 is degrees east. So Canary Island hotspot definitely looks like it's a little past 20 degrees west. So I see degrees north and degrees west. And so the best option that shows me that degrees north and degrees west, choice 3. 32 degrees north, 18 degrees west. All right, basic answers to questions 18 through 21 on the topographic map below and on your knowledge of Earth science. Points A, B, C, and D represents locations on the surface of Earth. Elevations are measured in feet. So this is a topographic map question. 18. So 18 says, what is the approximate gradient from point A to point B on the map? All right. Well, let's first look at the formula for gradients. We have to look at page 1. All of the formula, if a question ever tells you to calculate, you want to make sure you look at page 1 of the reference tables under equations. And so it says it's the change in field value over the distance, all right? So remember, when I'm using how far apart the two cities are, this is where I'm going to find my distance, all right? Where I'm going to find my field value is going to be on the map. We call it field value, right? Because it's the actual numbers that's on the map, all right? So for point A to B, well, let's take a look. A has a field value of 250 because it's on the 250 line. B has a value of 300 because it's on the 300 line. So I'm just going to work in this space right here for gradient. Right? And remember, it's change in field value over distance. And I know I'm butchering it. So let me just write it with a space right here. Here we go. We'll just substitute that. So what is the field value for A and B? We're gonna explore. Let's go deeper. All right. Well, A was 250 and B was 300. So how much did it change, right? Going from A to B, going from 200, 250 to 300. How much did the field value change? Well, if it went from 200, 250 to 300, right? And I want to know how much it changed. Subtract the bigger number minus the small number. It tells us elevation is measured in feet, right? So I want to make sure I have the correct unit. All right, and over. And the distance, right? The distance is going to be, sorry, let me make sure I'm pointed here. The distance is going to be how far apart is A from B using the scale. All right, so let me erase all this. And I'm going to measure, sorry, I apologize. Give me a little bit of time. So I'm going to measure A to B, right? So if you have your scrap paper, you're basically, right, marking your scrap paper from A to B, and you're going to compare it to the scale. So that red line that I drew, I'm going to bring it to the scale. All right, I'm going to bring it to the scale. Right? And if I fix this up, right, without changing it, generally speaking, I bring it to the scale. And look, A and B are actually right. It looks to be a little over two miles apart, right? So let's say 2.1 miles is my distance. So therefore, we'll go back here. Oops, nope. And my distance was 2.1 miles. All right. When you do that, you get an answer using, oops, sorry. You get 50 divided by 2.1. And when you go to your calculator, give me 1 second. 50 divided by 2.1. And you end up getting, I'll put on the bottom right here, you end up getting 23.8 feet over miles. All right, 23.8 feet over miles. And the best answer that's closest to that is choice one. All right, number 19. It says, in which general direction does Red Creek flow? All right. So I'm looking at Red Creek and I see Red Creek is flowing here, right? That white area, the white space right here, right? This white part right here. All right. And if we look, there's two ways that you can tell this. So you see how when the creek passes by an isoline, you see how this sort of looks like a V right here, right? When you want to find the direction of a river, a creek, a stream, it's always going to be in the opposite direction where the V is pointing, the base of the V is pointing. So if this looks like a V, right? The base of the V is pointing top to the right. So what is the opposite direction of where the base of the V is flowing? Down and to the left, southwest. So southwest is going to be your answer. It's always going to be the opposite direction where the base of the V is pointing. If you look on 6E, it says it, counter lines point in the opposite direction of the stream flowing across them. All right. So that's just one thing to keep in mind. Once again, you can take a look right here. Look at this counter line right here. You see how the base of the V is pointing top and to the right. So we got to look at the opposite direction, down and to the left, which is going to be southwest. Another way you could have said this is look how the V-shaped isolines look where they're opening up, right? They look like they're being poured out, right? At where the V's are opening up in this direction. That also means southwest. That's why the correct answer is choice three. What is a possible elevation for the surface of Darien Lake? Darien Lake. Well, let me clear up all this stuff. All right. So, oh, sorry. Darien Lake is here. All right. And they tell us the counter interval is 10 feet. All right. The counter interval is 10 feet. So that means that each line is going to be going up by 10 feet. All right. Each line goes up by 10, each line goes down by 10. So the fact that Darien Lake is before 250, before it's 250, and I do not see any 240 isoline. There is no 240 isoline anywhere around here. That means that Darien Lake has to be bigger than 240 and less than 250. And so that's why the correct answer is going to be choice 2. All right, 21. It says, which cross section represents an accurate profile of the landscape between points C and D? Right? So remember, all of these lines represent elevation. And as I'm going from C to D, right, I want us to pay attention to what is actually taking place. Let me zoom in. Okay. So I see that I started at 300 feet, right, where C is. I know that as I'm moving, you'll notice if you follow some of these lines up here, right? I see 300 here and I see 250 is here. So I know that the numbers are going down. And in this area that's hatches, that also lets you know as you go towards the center, usually the numbers are supposed to go up, right? As you head towards the center of the isolines. In this case, as the go towards the center of these type of hatched isolines, the numbers actually go down. So I see 300 is here, 290 is here, right? Because the counter interval they tell us is 10 feet. So it always has to respect that rule, right? It's either going up or down by 200. 280 is here, 270 is here, 260 is here, and 250 is here. So as I'm going from C to D, I notice, right, it goes back up to 260 because these are the same lines, right? 270 is here, 280, right? Because now I'm heading back towards the center, which means my numbers are going to go up. And 290 is where D is going to be, right? It's one line away from 300. So as I'm walking from C to D, my numbers are going down, starting from 300. My numbers are going down. This area in here, so these points right here is going to be less than 250. This area right here is going to be less than 250. And then it climbs back up to 290. So which one basically shows me, hey, you started at 300, you're going down, and it climbs back up to 250, and then climbs back up to 290. And so when I take a look at my answer, the correct one that shows that started at 300, ended at 290. There's only one dip before it climbs back up, is choice 1. All right. It can be choice 3 because look, C did not start at 300 when it was clear right here that C is at the 300 line. Basic answers to questions 22 through 25 on the field map below and on your knowledge of earth science. The map shows the depth of Lake Ontario. Isoline values indicate water depth in feet. Points A, B, C represents locations on the shoreline of Lake Ontario. Points D and E represents locations on the bottom of the lake. What is a possible depth of the water at location E? Well, E is located between which two numbers? E is located between 600 and 700. And so therefore, oh, sorry. Because E is in between 600 and 700, you could have said any answer from 601 to 699. And remember, it's measured in feet because the reading tells us right here that the water depth is measured in feet. So always make sure to highlight, right, what the units, what these values are being measured in. All right. And the reason why you can't say 600 is because E is not on the 600 line. You can't say 700 because E is not on the 700 line. So that's why you could have said any answer from 601 to 699. All right, 23. So 23 says, what evidence shown on the map indicates that the southern section of the bottom of Lake Ontario has the steepest slope, right? If we take a look, oops, sorry, at fact 6DI, is it fact 6DI? Here we go. Look, says it right here. The closer the isolines, the steeper the slope or gradient. The farther the isolines, the more gentle the slope or gradient. So what evidence do I know that the bottom of the lake, well, the bottom of the southern section of the bottom of Lake Ontario has the steepest slope? Look at the southern section. Right? The southern section right here. Look at how look how the lines are packed. They're very close to each other, right? And so this clearly means that the slope is going to be very steep. So that's why the correct answer is right here. That's the evidence. The closer the isolines, the steeper the slope or gradient. That is the evidence. 24. On the grid in your answer booklet, draw a profile of the bottom of Western Lake Ontario by applying the depth of the water along line AB. Plot each point where an isoline showing depth is crossed by line AB. Connect the points with a line starting at A and ending at B to complete the profile. So what you were supposed to do, right? Let's say if you took a scrap sheet of paper. So I'm going to pretend, and just bear with me, right? So bear with me that I have a scrap sheet of paper, right? That is yellow, right? So just bear with me. Let's say this is my scrap sheet of paper. What I'm going to do, and I'm going to zoom in, using my scrap sheet of paper, I'm going to start at A and I'm going to end at B. And what I'm going to do is I'm going to mark for every line. Let me do black or dark blue. Here we go. For every line that touches AB, right, I'm going to make a mark and I'm going to label the value of all these, okay? So for example, A, when I follow A, right, do I know the value? Well, what's the counter interval? Does it tell me the counter interval? The map does not tell me the counter interval. Well, let's see. How much is each line going up by? Well, I see right here, 600, 500, 400, 300, 200, 100. So the pattern that I'm seeing is each line is going up or down by 100, right? So if this line right here is 100, A would have to be at 0, right? So the next line here is actually 100. You would write that on your paper. The next dash right here is on the 200 line. So you would write 200. The next dash would be 300. The next dash would be 400. That's labeled right here. All right. This is the same line So that also means that this line also represents 400. This line is at the 300 line. This line represents the 200 line. This line represents the 100 line, and B is at 0. All right. Then what you would do is now with your scrap sheet of paper, you would grab it, and then you would definitely make sure to mark on your paper A, mark on your paper, this is A, and mark on your paper the last line, this is B. And what you would end up doing is you would take that paper and you would then drag it. I do not know how to do this on the computer, so that's why you would have to use your imagination. But you would drag this paper and then you would place it underneath. Oops, sorry. Here we go. You would place, oops, here you go. Yeah, I can't grab it. You would place it underneath right here. And one of the things that you'll notice is when you line up AB with AB, right? So if you had your scrap sheet of paper, I'm just going to pretend, right? And highlight. So you have your scrap sheet of paper, right? The yellow represents your scrap sheet of paper. And remember the dashes that you would have had, right? With numbers underneath it. I'm just giving an example. You know that A would be at 0, so you would plot 0, right? The next dash would be 100. You would track. The next one would be 200. You would track the next one 300. You would track the next one 400. 400 again, back to 300, 200, 100, and 0, right? You would track for each one. This one. Sorry. Oops. You got any paper? Right. And then you would track. Yep. And now that you have all your points, then you would just connect the lines. Because I'm starting to go down, when I have 2 points that are the same, I'm going to draw a small loop. Don't cross the next line and go back up. And that would be your stream profile. If you had plots that were going upwards like this, oops, sorry. If it was going upwards and you had two plots that were the same on the same y value, right? Then you would just do a small loop going upwards without crossing the next line, all right? But in this case, because of the fact that we are going downhill, and we know at those 2 points, which would be right here where the 400 is, right? You will notice that this area in between is also in between 400 and 500. That's why that area would have to be greater than 400, but less than 500 here. And we would have to show that on our profile. That's why it's curved like that. And that would be your answer, pretty much for the most part. All right, 25. So 25 says a raft was set off in Lake Ontario at point C. It took 30 minutes to reach point D. Calculate the rate, keyword, rate of movement across the lake surface from point C to point D. Label your answer with the correct units. All right. So I do see a formula, right, for the rate of change, which is the change in value over time, right? The change in value over time. Now, according to this problem, they already told us how long, right, that the movement of water, right, was flown, right? The raft took 30 minutes. So that means on my reference tables, when I'm substituting values, my time is going to be 30 minutes on the denominator. Now I need to know what is changing in value over 30 minutes, right? If I'm trying to calculate the rate of movement, I need to know how far, right? Keyword, how far is point C to point D. That means that I have to use the distance. I need to know how far it traveled from C to D, not the elevation, right? That's dealing with gradient. But for rate of change, I'm going to know the rate of movement. I need to know how far C to D is. So using my scrap paper, I'm going to draw a straight line from C to D, right? And then I'm going to take that line and I'm going to bring it to my skin. Oh, no, no, no. Sorry, sorry. How do I undo? I apologize. Let me do this again. A straight line from C to D. And then I'm going to move it. All right. Here we go. And while I move it, right, I'm just going to, now with your paper, it'll be a lot easier to shift because I'm doing it online. Actually, hold on. Let me see if there's a way for me to just change the position on it. I don't know how to do it. All right. But essentially what you would be doing is just changing the hold on, let me see. Yep. Yeah, it'll be stretched out like that. All right. Now in this case, ready, it should be somewhere around 20 miles. That's your distance. 20 miles, 20 mi. All right, when you use your scrap paper. So therefore, my change in value, because I'm focusing on the distance, would be 20 miles. And when you solve for the rate of movement, 20 miles divided by 30 minutes would get you 0.67, I rounded, miles over minutes. And that would be a correct answer for 25. That is all 25 questions. Have a wonderful, blessed day. Make sure to like, share, and subscribe. Take care, everybody.